Okay, so welcome back to the stream, and today we are going to be doing paper 5 in paper 6 in maths. So for this one, you actually get the option to take statistics, or you'd either take statistics, which is paper 6, or you would take mechanics, paper 4. So my teacher made me take paper 6, so I'm taking statistics. Yeah, so today we're going to be doing some statistics, and regarding today's paper, today I took paper 5 maths. It's also statistics, and it's just the more easier version of paper 6. So it's actually alright, not too bad, but one huge mistake that I really should not have made was I forgot EX. I forgot what EX was, which is for geometric distribution, which would be just 1 over P. I can't believe I forgot that. But it's okay, that's just 1 mark. So the rest should be fine. Right, let's just start with this paper. Line 70962 F and 23. Now I have to get another pencil. This pencil's running out already. So today I have another half carton. Wait, let me lock the door. I have another half carton of milk, but now guess what's inside? It's mango ice cream, homemade. My mom made mango ice cream. It's really good. And my calculator is still broken, so I'm just gonna have to use my phone. Yep. Okay. Okay. Starting off with question 1. Anita carried out a survey of 140 randomly selected students at her college. She found that 49 of these students watched a TV program called Bunch. Calculate an approximate 98% confidence interval for the proportion P of students at Anita's college who watched Bunch. Okay, so for the first question, let's just draw the graph first, normal distribution. And we know that 98% watched the show. So we take one side and we shade it, 98%. So that side that we do not shade is actually 0.02. So 0.02, and since we want the confidence interval, which is the middle value, so we'll have to minus 0.02. Wait, I'm gonna have to, let me just get my calculator on my computer. Now I'll just use my phone. Okay, calculator. Okay, 0.98. We can just do it in our mind actually. So 0.98 times a minus 0.02, you get 0.96. And so then our mean will be our P will be 0.96. We found that 49 of these students watch a TV program called Bunch. Okay, so the probability will be equals to 49 over 140, which gives us 49 divided by 140, 0.35. So we use the formula Z plus minus P plus minus Z root of PQ over N. So our Z would be 0. We need to find what's the inverse phi of 0.96, which is 0.96. Okay, plus 1, so 1.75751. Let's double check 1.751. Okay, so we will get P, let's just write 0.35 plus minus PQ 0.35 times 0.65 over N, which is 140, and we found that it's 1.751, so that'll be the one different, 1.751. Let's go back to the question. So the proportion P would be equals to calculator, the root of, let's multiply it first, let's just write straight away, 0.35 plus, we go with plus first, 1.751 root 0.35 times 0.65. Oh my bracket 0.35 times 0.65 divided by 140. That gives us the maximum, which is 0.421, and the minimum, which would be, let's go back to the previous one, let's change it to minus. Minus 1.751 bracket root bracket 0.35 times 0.65 bracket divided by 140. That gives us 0.279. Okay, so the answer will be 0.421 and 0.279. I really don't like using the phone calculator. It's very inefficient. Okay, moving on. B. Carlos says the confidence interval found in A is not useful because it is too wide. Without calculation, explain briefly how Carlos can use the results of Anita's survey to find a narrower confidence interval. So if you want a narrower confidence interval, it's quite self-explanatory. Just use a smaller confidence interval, a lower confidence interval. Yeah, the answer would be use a smaller confidence interval. Okay, next one, 2A. Do some Poisson. The number of orders arriving at a shop during an 8-hour working day is modeled by the random variable x with distribution PO25.2. State two assumptions that are required for the Poisson model to be valid in this context. So, in order for you to use Poisson, the mean of occurrence must remain constant, and events must be independent of one another. Okay, next one, B1. So wait, let me check how long do we have for this paper. 1 hour 15 as well, same as paper 5. Find the probability that the number of orders that arrive in a randomly chosen 3-hour period is between 3 and 5 inclusive. So you want P3 less than or equals to X less than or equals to 5. And then since you want 3 hours, we'll just do cross multiplication. 8 hours gives us a mean of 25.2. So 3 hours, we'll have to cross multiply. 3 times 25.2 divided by 8, 9.45. So your Poisson would be E negative 9.45. So E to the power of negative 9.45 bracket 9.45 to the power of 3 over 3 factorial plus 9.45 to the power of 4 over 4 factorial plus 9.45 to the power of 5 over 5 factorial 3.5. So that will give us, I don't have a calculator. Oh, okay, I need a calculator for this. Hold up. Let me just try and search out a calculator online. Scientific calculator. Okay. E to the power of negative 9.45 bracket. Where is the fraction button? Yeah, which one is okay? I think it's this one. Oh, sorry. We have to put it down first. 9.45 to the power of how do you delete that? Back. 9.45 to the power of 3 divided. Oh my gosh. 3. Okay, let's go all the way back first. 9.45 to the power of 3 divided by 3. Okay, I'm gonna get an actual calculator. Just give me a second. Okay, e power of negative 945 bracket 945 cube over 3 factorial plus 945 9.454 4 factorial plus 9.45 55 factorial. You get your answer will be 0.0866. Moving on. Okay. Find the probability that in two randomly chosen 1 hour periods, exactly one order will arrive in one of the 1 hour periods, and at least two will arrive in the other 1 hour period. So firstly, we find the probability of orders arriving in 1 hour periods. So 8, 25.2, 1x, x is equals to 25.2 divided by 8, you get 3.15. Exactly one order arrived in one of the 1 hour periods, so that's exactly one order. So we have e to the power of negative 3.15, so that's one order, and plus two, at least two orders. So we would have 1 minus e to the power of negative 3.15. Let's say 0 orders arriving, which will be 1 plus 3.15. At least 2. So from that we get e to the power of negative 3.15 times 3.15 plus 1 minus e negative 3.15, 1 plus 3.15. Oh, that's a big probability. At least two orders. So 1 minus 0 and 1. So our answer would be equals to 0.957. Okay. Next one, C. The shop can only deal with a maximum of 120 orders during any 36-hour period. Use a suitable approximating distribution to find the probability that in a randomly chosen 36-hour period. There'll be too many orders for the shop to deal with. Okay. Firstly, 8 is to 5.2. So 36 is x, and therefore x is equals to 36 times 25.2 divided by 8, you get 113.4. So suitable approximating distribution. So for this one, since we know that our mean is 113.4, for our normal distribution, we will have both means being the variance and the mean. So we will get 113.4, 113.4. So from here, we can just straight away do P, X is too many orders. So more than 120, and then straight away 120 minus 113.4 over the root of 113.4. 120 minus 113.4 over root of 113.4. Our P is X more than 0.61, it's 6197, so we'll just make it 620. So 0.620, that gives us 1 minus phi of 0.620, which is 0.627324. Okay, 7324. 0.7324, which is equals to 1 minus 0.7324. 0.2676, and that is 0.268. Okay, next one. 3. How much marks is this paper? 50. Oh, it's exactly the same as P5. Okay. The diagram shows the graph with probability density function f. Okay. Symmetrical about the line x equals to 1.5. So that means everything below here is 0.5 and everything above here is 0.5. So we are to find 0.6 and 1.8 over here. So we're given that this part is A, less than 0.6 is A, and the middle part here is B. So we have to find this part first. So the separation is 0.3, and to 1.8 is also 0.3. So let's find this part first, which is 0.5 minus the sum of A and B, because it's everything here. So I'll write it down. 1.2 to 5 is equals to 0.5 minus A plus B. And then since we have this already, we will just find this. So this is the same as this. So you will get 2 of 0.5 minus 2 plus B. Minus A plus B, which is the whole area here. And then you will add it with B again, because you need this as well for 0.6 to 1.8. So yeah, that's why for your answer you will get 0.6 less than x more than 1.8. You'll get 2 times 0.5 minus A plus B plus B, which is 1 minus 2A minus 2B plus B. So the answer is 1 minus 2A minus B. Okay, moving on. B. It is now given that the equation of the probability density function of x is where k is a constant. So that k is equals to 10 over 81. So for this one, we know that anything below here is 0.5, and we are given the equation, or we don't have to do that, we just know that the area under the whole graph is 1. So that would be a bit simpler, since you only have to deal with whole numbers and not numbers with decimals. Okay, so to find the area under the graph, we will have to integrate kx squared 3 minus x squared with limits of 3 and 0. Integrating this will give you, okay, let's move the k out, and then we will expand the whole thing. So we have k 3 0, the limits, x squared, we expand the bracket, 9, 3 times 3, 9, 3 times x times 2, negative 6x, positive x squared is equals to 1. So k bracket, sorry, just leave it at the integration first, 9x squared minus 6x cubed plus x4 gives you 1. So now we integrate k bracket. Integrate 9x squared, you get 3x cubed. And negative 6x cubed, you get 6 over 4, 3 over 2 minus 3 over 2x4 plus x5 over 5 equals to 1. So with limits 3 and 0. So we know that if we put 0 in, everything will just be equal to 0. So we don't have to include the 0. We'll just find k, 3 bracket 3 cubed minus 3 over 2, 3 to the power 4 plus 3 to the power 5 over 5 equals 1, and k will give us 3 to the power 3 cubed minus 3 over 2, 3, 4 plus 3 to the power of 5 divided by 5, 81 over 10. So we have k 81 over 10 is equals to 1. So when we divide 1 by 81 over 10, we will get k is equals to 10 over 81. And there we go. We have shown that k is equals to 10 over 81. Next one, find the variance. So this one we already know that the mean is 1.5 because what's below here is 0.5. So that means the mean is 1.5. So for the equation of variance, we'll take 3 and 0, and we will put x squared times the equation. X squared, we'll take k out as well, times the full equation, x squared 3 minus x squared. And from what we expanded just now, we can just use that. 9x squared minus 6x cubed plus x4. And then dx, we have to minus this by the mean squared. Okay. So moving on, we will have k 3, 0. Expanding it, you'll get 9x5, sorry, x4 minus 6x5 plus x6 minus 1.5 squared. So let's integrate this. We will get k 9 over 5 x5 minus x6, because we'll have 6 over 6, which is 1, so just x6 plus x7 over 7 minus 1.5 squared. Okay, that's all integrated already. 3, 0. Now we just put the 3 in, just ignore the 0 since it just gives us 0. And from here we have 9 over 5, 3, 5 minus 3, 6 plus 3, 7 over 7 minus 1.5 squared. Okay, let's just find the bracket first. 9 over 5 times 3 to the power of 5 minus 3 to the power of 6 plus 3 to the power of 7 over 7. We get 20.82 something. And then we will multiply this by 10 over 81. We'll get 18 over 7. And we will minus this by 1.5 squared, which gives us 9 over 28. That's our variance. Okay, moving on. 4a. The number of accidents per 3-month period on a certain road has a distribution Poisson lambda. In the past, the value of lambda has been 5.7. Following some changes to the road, the council carries out a hypothesis test to determine whether the value of lambda has decreased. If there are fewer than 3 accidents in a randomly chosen 3-month period, The console will conclude that the value of lambda has decreased. So first one, find the possibility of a type 1 error. So easy way to remember type 1 error is just as a false positive. It's false positive, yeah. Sorry, let me just look it up. I feel ashamed having to look it up because we learned this in psychology as well. False positive, right? Yep, it's a false positive. Okay. False positive is type 1, type 2 is false negative. So false positive, it will mean that the console concludes that the value of mean has decreased. So to get type 1 error, we will need there are fewer than 3 accidents. So P of X is fewer than 3. In the past, the value of lambda had been 5.7. The console carries out a test and tell me whether the 3 accidents when we chosen 3 ones. Okay. How will we do this? Okay. Okay, so I guess since it's less than 3, we would still do Poisson since the lambda is 5.7 and we'll still use Poisson on this. So we would have E negative 5.7 times less than 3, which would be 0, 1, 2. So first one is just a 1 plus 5.7 plus 5.7 squared over 2 factorial gives us E negative 5.7, 1 plus 5.7 plus 5.7 squared over 2 factorial, 0.0768. That's a possibility for a type 1 error. So now next one. Find the probability that a type 2 error if the mean number of accidents per 3-month period is now actually 0.9. For B, find the probability that a type 2 error false negative is now actually 0.9. Okay. So since it's 0.9, we would use false negative, so it has to be more than, oh my gosh. False negative. So we will need to have more than 3 accidents for it to not be able to conclude that it has decreased. So we would do 1 minus E negative 0.9. So we'll just do 1 minus the fact that it has less than 3. So 1 plus 0.9 plus 0.9 squared over 2 factorial So this one is we're taking 1 minus the probability that it is less than 3. Fewer than 3, which is 0.0, 1, and 2. Okay, and then that will give us 1 minus e to the power of negative 0.9 times 1 plus 0.9 plus 0.9 squared over 2. Gives us 0.0629. Okay, moving on, 5a. How many more are there? 6 is the last one. Okay, because I have to eat dinner now. Oh, this one's easy. Find the probability that a randomly chosen large packet has a mass that is more than double the mass of a randomly chosen small packet. So since it says double, then the variance you will have to square the the 2 as well, because it's double, not like 2 times or 3 times like that. Okay, so our probability that randomly chosen large bracket has a mass that is more than double. Okay. P L has a mass that is more than double the mass of randomly chosen small packet. So we find the mean, the new mean, which would be L minus 2s, because we move the L is more than 2s, right? We move the 2s to the other side, we get L minus 2s, it's more than 0. So L minus 2s will be equals to, the mean of it would be 410 minus 2206, which is -2. And then for the variance, we would have 3.6 squared minus 2 squared, 3.7 squared. Sorry, not minus, plus. For variance, it's always plus. 3.6 squared plus 2 squared, 3.7 squared. You get 67.72. And then from this, we would do our normal L minus 2s is more than 0, and then we do normal distribution as usual. L minus 2s more than 0 minus -2, so it's plus 2 over root of 67.72. That gives us P Z value is more than 2 over root of 67.72, 0.243. So from this, we will take it to the normal distribution curve. So we'll get 1 minus phi of 0.243 equals to phi of 0.5948, 0.5960, 0.243, 0.5960. 1 minus 0.5960. That gives us 0.404. Okay, next question, B. The packets are placed in boxes. The boxes are identical in appearance. 60% of the boxes contain exactly 10 randomly chosen large packets. 40% of the boxes contain exactly 20 randomly chosen small packets. Find the probability that a randomly chosen box contains packets with a total mass of more than 80 grams. Okay, so we find the probability that, okay, let's say we get the 60% of boxes, which is 10 large packs. So we find the probability that 10 large packs is more than So we find the mean of 10 large packs first, which would be 10 times 410, which is 10, 410, 4,100. And the variance will be equals to 10. So for this one, we don't square the 10 because it just has 10 randomly chosen large packets. It doesn't say 10 times of the chosen packet, something like that. Okay, 10 times 3.6 squared, which is equals to 129.6. And let's say 20 small packets. Gives us 20 times 206 equals to 20 times 206, 4120, and 20 times 3.7 squared. We will get the variance is equals to 273.8. So a randomly chosen box contains packets with a total mass of more than 4080. So we found the probability of 10 being we've already found the mean of 10 and mean of 20 small packets. So next one we will have to find the probability of getting each of these boxes. So yeah, okay, sorry. So since we found that already, we find the probability that 10 packets is more than 4080. X more than 4080 minus 4100 over root of 129.6, which gives us a z value of 4080 minus 4100 divided by root of 129.6, negative 1.759. And for the 20 small packets, x more than 4080 minus 4120 over root of 273.8, giving us a z value of 273.8, root of 273.8, negative 2.417. So from this we would find the phi of 1.759 and the phi of 2.417, which is equals to respectively 1.7595559, 759, 9599, 9607. So 0.9607, and for 2.417, 0.991, 0.9920, and 7 is 1. So 0.9921. 0.9921. So from this, we will take the probability of getting each of these boxes, which is 60 and 40. So we'll do 0.6 times 0.9607 plus 0.4 times 0.9921, which gives us 0.6 times 0.9607 plus 0.4 times 0.9921, 0.973. Okay, moving on, 6A. This one should be fast. Last year, the mean time taken by students at school to complete a certain test was 25 minutes. Akash believes that the mean time taken by this year's student was less than 25 minutes. In order to test his belief, he takes a large random sample of this year's students and he notes the time taken by each student. He carries out a test at a 2.5 significance level for the population mean time. Akash uses the null hypothesis, H0 mean equals to 25. Give a reason why Akash should use a one-tailed test. He believes that the mean time taken was less than 25 minutes, so our answer will just be Akash believes there is a decrease in time taken. Okay. B. Moving on. Explain what conclusion he should draw since his test value statistic is 2.02. So negative 2.02. Let's say it's more than. Oh, sorry, less than. So because it's less than 2.02, sorry, you're trying to find less than. So since you have a negative 2.02, you will have a 1 minus phi of 2.02, which gives you 1 minus 2.02, 0.9783. 1 minus 0.9783, which gives you 0.0217, which is just 2.2%, something like that. So since it's less than 2.5%, therefore reject the null hypothesis, as there is enough evidence to support that time taken has decreased. Okay, moving on. C, the last. Oh, it's not the last question. C, given in a different one-tailed hypothesis, the value was found to be 2.14. Given that this value would lead to a rejection of the null hypothesis at the something significance level, find the set of possible values of alpha. Okay, so we know that 2.14 is about to be rejected. So let's just find what more than 2.14. How will we do this? Okay, so 2.14 is around 0.9838. So 98%. So you're having a 98% in one side. So that just means that in order for it to be accepted, meaning you reject the null hypothesis, you will need for it to be it says alpha right here. 9838 will have to be lower for you to accept it. How would you do this? Okay, so this just means that your two possible values of A is either 99% or 1 minus 0.9838, 0.0, so 1.6%. So in order for you to accept it, you need to have either 99% or 1.6%. So since it says the set of possible values of A0. Okay, moving on. The population mean time taken by students at another school to complete a test last year was m minutes. Sorin carries out a one-tailed test to determine whether the population mean this year is less than m. Using a random sample of 100 students, he assumes that the population standard deviation of the time is 3.9 minutes. Okay, the sample mean is 24.8 minutes, and this result this leads to the rejection of the null hypothesis at the 5% level. It's less than m. So you would do p, x is less than 24.8 minus m over the 3.9, since it's already the standard deviation, but since this is using random sample, there's 100 students, and so you have to divide it by root of 100 as well. P z less than 24 point, we don't have to really do this. He assumes that the population standard deviation is 3.9. This is another null hypothesis. Rejection of the null hypothesis. So it's less than 5%. So let's just say it's 5%. It's less than m, so it's a negative value. So let's find what gives us 0.95. 0.95 is 1.645. So you would have, so then from here you would just do your 24.8 minus m over 3.9 over root of 100 is equals to negative 1.645. Moving your standard deviation over, you would have negative 1.645 times 3.9 root divided by root of 100, negative 0.64155. And you would minus it with 24.8, and you would divide it by negative, which gives, so then your m would be 25.4. There you go, 25.4. Okay, so let's just look at the, I want to just check questions, the last question was 6, because I'm pretty sure my C is not really correct. So I just want to get that straight first. So 25.4, alright, that's correct. So it's more than or equals to 1.62. Alright, so I did get 1.6, and I did find it this way, yeah. 1.62. Alright, so it's just x is more than or equals to 1.62. Yeah. It has to be more than 1 or equals to 1.62 for it to be to reject the null hypothesis. First, so 6a, he's expecting a decrease, so yep. And then next one, negative 2.02 is less than 1.696, or you can just do 0.0217 is less than 0.025. Therefore, you can reject H0. Alright, so I'm gonna go eat dinner first, and I'm gonna do one more paper. Okay. Just give me some time. Okay. Let's start marking all over again. 5B, 0.973. Alright, that's correct. 5A, 404. Okay. 4B, 0.0629. Alright. 0.0768. Alright. 3B1. Okay, K is 10 over 81. 3B2, 9 over 28. Alright. 3, 1 minus 2A minus B. Alright. 0.252. For C, although I did get 0.268. So their mean is 0.667, but I got 0. Oh, they have 1, 2, 0.5. Huh. Okay, so I guess if it's approximate, you would have to plus 0.5, yeah. Okay, 2B2, 0.222. Alright, I did not get that one correct. E, negative 3.15. Though I did get, the values are correct. E, negative 3.15 times 3.15 times 1 minus E, negative 3.15, 1 plus 3.15. Huh. Oh, you just times it, you don't plus it. Oh. Okay, okay. Oh, okay, okay. 0.0866. All those arrive at constant mean rate. Okay. Arrive independently. Okay. Smaller percentage or lower level of confidence. Okay. And 0.256, 0.444. So I did not get that. Z is 2.326. Huh. What? So you would use 0.99 even though the confidence interval is 98%. 98, so you would have, also that just means that the middle is 98 and you will have 1 on 0.01 on each side. So for you to get the confidence interval, you will take, okay. Alright, let's move on to the next paper. This will be May, June now. Let's go with 6-1. Where's this? 9709. 6-1. May, June 23. Alright. In a certain country, 20,540 adults out of a population of 6,012,300 have a degree in medicine. Okay, so that's our probability already. P is equals to 2540 over 6012,300, which gives us 2540 6,012,300. That's a small probability. Okay, 3.416 times 10 to the power of -3. Use an approximating distribution to calculate the probability that in a random sample of 1,000 adults in this country, there will be fewer than 4 adults who have a degree in medicine. and a random sample of 1000 adults. So this is clearly a very big distribution, so let me check the so if your n is more than 50, you would use a Poisson approximation. But we'll have to find out NP first. So NP would be 1000 times 3.416 times 10 to the power of -3, giving us 3.416, and NP is less than 5. So then we can use Poisson approximation. So we know that our lambda is 3.416. So our mean and standard deviation, variance is 3.416, but since this is a approximating distribution, we will have to do Px is fewer than 4. Fewer than 4, so it would be 4 minus 3.5, which would be 3.5 minus 3. Let's just mark while we do the work. Three point five minus 3.416. That's the mean over your square root of 3.416. So that gives us our z value of 3.5 minus 3.416 divided by root of 3.416. 0.045. So for 0.04 and then 5, you will have 5.1, 5.80. So phi of 0.045 would give us 0.5180. So it's just 518. Let's see if that's correct. We'll go to MS61. Slowly we'll go down, and then okay, first one 0.555. So this one they just used Poisson. Okay, this is a bit confusing already. I'm sorry. Okay, that's our first wrong. Use Poisson. Like I said, use Poisson approximation, but I don't know why I still went on to use a normal distribution. Oh my gosh. Justify the approximating distribution used in part A. So for that you would just write that NP is less than 5 and N is more than 15. So did we get that correct? So N is more than 50, NP less than 5. Alright, moving on to A. The graph of the function f is a straight line segment from 0, 0 to 2, 1, show that f could be a probability density function. Okay, so we will just have to show that the area under the graph is 1. So for this we will do half times base times height, giving us 1. Hence, probability density function, PDF. 1/2 times 2 times 1 is equals to 1. That's 1 mark. Fx is more than or equals to 0. So I didn't get that 1 mark, so it's just 1 mark. So we have to write down fx is more than or equals to 0. Okay, for b, the graph of the function g is a semicircle, center 0, entirely above the x-axis. Given that g is a probability density function, find the radius of the semicircle. So, since it's a probability density function, you will get half pi r squared, which is the area of a circle. Half pi r squared is equals to 1. So we would do move everything over, you'll get r root of 2 over pi. So r is equals to root 2 over pi. Root 2 over pi. R is 0.798. Did we get that? Yep. Okay, moving on. C. Without calculation, use the diagram to explain how you can tell that the median time is less than 15 minutes. So in this one, we know that the area under here is 1. Tell that the median time is less than 15 minutes. So I think it's because that it's not a constant gradient, so it's not even a straight line, so you can't say that it's the median. The middle is 15, so it has to be less than 15 because it's not a straight line. But how will we put that into words? Okay, I'll write down graph is not proportional, hence median cannot be 15, must be less than 15. Let's see what they wrote. Area to the left 15. Oh my gosh. Area to the left is greater 15 is greater than 0.5. Alright. Okay. Number 2. It's now given that find the mean time. So the mean time would be just Ex is equals to x 40 over x squared minus 1 over 10, where maximum value is 10 and minimum is, maximum is 20, minimum is 10. So the mean time would be okay, so the mean time would actually be, you have to multiply everything by x first, so you would get integration sign 10 x times 1 over x squared, you get 1 over x, so 40 over x minus x over 10 dx, and if you integrate this, you would get ln Right now you don't get a loan. So we'll just move the x above. x1 and x1. Oh no, you have to do a loan. Oh, but we can't do a loan. Okay, just 40 loan x. Oh, it's integration. Oh wait, no, yeah, because integration you can't do that. 40 ln x. I think that's, yeah, it's 40 ln x minus x squared over 20. And if you substitute the values in, you will get 40 ln 20 minus 20 squared over 20 minus 40 ln 10 minus 10 squared over 20, which gives you 40 ln 20 minus 20 squared over 20 minus 40 ln 10 minus 10 squared over 20. Your answer will be 12.7. Is that the correct answer? 12.7. Alright, that's correct. Moving on, 3. In the past, sorry. My mom's texting me. Okay, so my mom's actually asking me to, because they ate dinner without me already, so she made another set of dinner for me. So I'm gonna go eat it now, but maybe next time I will start my stream earlier. So yeah, I realized that I'm not getting much stream time, but I am managing to do like one past paper per day. But I will finish this past paper probably off stream. But yeah, I'm sorry about that. Yeah, I'll start my stream earlier next time. So I have to do at least 2 papers on stream next time. Yeah, sorry about that.